Alright, 7.1 is radical expressions and radical functions. When we look down here, that's just the formal definition above. A radical expression has a radical sign, and underneath the radical sign is a radicand. Now, if there is no number in this position right here, this is your index. It's a known 2. Okay, if there's no value there, it's a known 2. Your index is a known 2. We want to look at a few examples to get an idea of how this works. We have the square root of 36 equals 6 because 6 squared equals 36. Square root of 0 is 0 because 0 squared equals 0. And so on and so forth. As you read through each of these examples, we can see that squares and square roots are inverses of each other, kind of like they undo each other, like addition and subtraction are inverses. Even when it comes to variables, we can see that we want to know what squared is going to give us x to the 6th power. And remember, when you have a power raised to a power, you multiply, so you get 2 times 3 is 6. Alright, a few of the helpful hints to remember is that the square root of 0 is 0. And the next thing is that the square root of negative 9 is not a real number because there is no real number that when multiplied by itself would give you a product of negative 9. Now these have a special kind of value, and we'll learn about those more in section 7.7. And so now we're going to look at a few examples. Okay, number 1, we want to know what number squared equals 100. So that's going to be 10 because 10 squared equals 100. Number 2, if we wanted to break that apart, we can actually look at this as the square root of 9 over the square root of 25 if we wanted to separate that. And what squared gives me 9? 3. And what squared gives me 25 is 5. Okay. And number 3, we want to know what squared gives us 1 tenths. Let's see, we got tenths, hundredths, thousandths, 10,000ths. 1 10,000th is going to be 0.01. Okay. Number 4, what square gives me 36? I want to do this part first. So I'm going to evaluate that. And then this negative sign out front is just going to be carried over. Okay. Number 5, since it's a variable, I want to write it out. I need to know something squared. Okay, so if I say x to the what power is gonna squared gives me 16. So I basically need to know 2 times what? 2 times 8 gives me 16. So when I say what squared gives me x to the 16th, my answer is going to be x to the 8th. Okay, so with variables, we can look at it the same. The idea is the same, the concept. So in number 6, if I had to rewrite, I would say what squared gives me 16. So if I wrote it out the long way just so you can see it, that would be 4 squared gives me 16. And then for my variable, I need my exponent to be a 2, so it's a y is down here. So I need to know y to the what power. Well, we got to figure out this, and the way we do that is we say 3 times 2 is 6. So my answer is, when I say what squared gives me 16y to the 6, I'm going to say a 4 and y to the 3rd. Okay. Basically, if we can rewrite these so that our exponents match our index, then they're inverses of each other, and we can simplify that. So we're now up on number 7, and now I need to know what to the 3rd power, what cubed. Since my index now changed to a 3, I need to know what to the third power, which means multiply it 3 times gives me 64. Well, that answer is going to be 4. So my answer is going to say the cubed root of 64 is just 4. Okay, same idea here. Like if I wanted to rewrite this, I can say what's the cubed root of 1, what's the cubed root of 8, and I'll say what to the 3rd power gives me 1. Well, 1 does. On the bottom, what to the 3rd power gives me 8. Well, 2 times 2 times 2, so my answer is going to be 1/2. Number 9 says, what number to the third power is going to give us negative 125? Okay, so the answer is going to be negative 5. So our answer is negative 5. Alright, number 10. The best way with variables, if variables tend to be a little bit confusing to you, is I know my index is a third power, so I need my exponent to match that. So now I just have to figure out what value goes here. And I need it what cubed gives me x to the 12th power. Well, 4 times 3 is 12, so x to the 4th power. If I cube x to the 4th power, I'm going to get x to the 12th. Number 11, what cubed, I work with my coefficient first, what cubed gives me negative 64? And that's a negative 4. What cubed gives me x to the 6th, which is going to be x squared. Number 12, now we're talking about 4th power. Since my index changed, I need to know what to the 4th power equals 16. Remember we're going to multiply it 4 times, so something times something times something times something, the same number is going to equal 16, and we have to figure out what that is. So when we figure out 2, our answer is 2. Now this negative that's sitting out front just gets carried over in front of the answer. So our overall solution is negative 2. Number 13, what number to the 5th power equals negative 32? So we need to figure out what goes in there, and that's going to be a negative 2. So our solution is negative 2. Number 4, what number to the 4th power can give us a negative 16? That's not going to be possible for us to get a negative number to the 4th power. So this answer is going to be no real roots. And like we said, later we'll talk more about specifically what those answers are. Okay, if you have a negative radicand and an even index, it's no real root. Alright, number 15, we want to know something to the 5th power because my index is a 5. So x, I need to figure out what goes there. Well, to get that, a power to a power you multiply, so our value is going to be x to the 4th. And then the last thing we have is going to be what to the 6th power, so I need to know what number multiplied 6 times gives me 64. That one's going to be 2. 2 to the 6th power, 64. And I also need to do that same thing with my variable. Remember my exponent has to be a 6, so it's x to the what's going to give me 12. So this and this to the 6th power gives me 64x to the 12th.